Is the misuse of ToList making your code slower and consume more memory? Yesterday, I saw a talk by Mike Treit called The Tragedy of ToList, in which he showed us several examples of how misusing ToList was making applications slower and consume more memory. Let's see 3 examples about it. Here we are in Visual Studio, and first I want to show you this example 1. We're going to have an array that is going to have 10 and then 100,000 elements. As you can see here, we are setting that up. And then in here, we have 4 examples of code that uses a very simple logic. As you can see here, for example, we are saying array where x equals 4 to list count greater than 0. So basically, we're trying to determine if in this array there is an element of value 4. We're making it to list and then count greater than 0. So we're determining if there is a 4 in that array, and then if there is, then we're going to run this piece of code. And then we're making some iterations of this logic. For example, here we have array where without the toList and then count greater than 0. So basically the same without this toList. And then we have another option in which we use array where any. Remember that any returns true or false in case that there is an element that matches our description. In this case, if there is a 4 in this array. And finally, instead of using a where any, we use array any and directly pass the predicate here and checks for the existence of an element of value 4. And you are going to see a dramatic improvement when doing this compared to this version that we have here, which again may seem like simple code that you can see anywhere else, but that is actually very slow because of the misuse of ToList. So let me run this, and by the way, I'm using benchmark.net to benchmark this code. Alright, so here we can see the first results. As you can see here, we have toList.greater than 0, which is the example that actually uses the toList. We can see that it took 39 nanoseconds to run this example, and in the case of the count being 100,000 elements, 51,000 nanoseconds. Compare that, for example, with the second example, where count greater than 0, which is the second one, in which we simply remove this toList from here. So here we have a toList, here we don't have it. And see the massive difference. We're talking about basically half, 27,000 nanoseconds. And then we go to link where.any, in which we can see here that the difference is quite impressive. We have only 18 nanoseconds, compared that to 51,000 nanoseconds. And finally, the most dramatic improvement comes from link any. This simple version that we have here, this array any, and passing the predicate, was the fastest of them all. Here we have that it only took 3 nanoseconds to process 100,000 elements. That is massive, that is impressive. And not only that, see the difference in memory allocation. For example, in the worst case, we have 112 bytes of memory being used. Meanwhile, with the link any, with the best example, there was 0 allocation made, and therefore this version, the link any, is the most efficient both in terms of speed and also in terms of memory consumption. Now let's see the second example. Here, as you can see, we have this value which has key and value, key and value, key and value, and then we have 2 implementations of an algorithm that does a split to this value, splitting by this semicolon, and then does a toList. And then we have a for each. We iterate this list that we have here, then again we go to the item, do another split, and then say toList, and then do something with this information, which in this case is count equal to 2, and this is equal to key, and then we do something here. Excellent. But now let's see the other version, the most optimized version. Let's come here without toList. So it is exactly the same, but we are eliminating the use of toList. So value split here and item split here. No toList here, as you can see here. These toLists were removed. And we're going to see that there is some improvement in this case just by removing the misuse of toList. Let's come here. Let me say example 2 and benchmark this. Control F5. Alright, so here we have the result of our experiment. As you can see, we have using toList and without toList. In the case of using toList, we have 4.9. Meanwhile, without toList, we have 3.5 for an improvement of about 28%, which is awesome. Just by removing toList our software is now 20% faster. And also there is improvement in terms of memory allocation. For example, here as we can see, we have 10 kilobytes and here 6.9 kilobytes for an improvement of 34%. Again, just by removing 2 unnecessary ToLists, we saw an improvement in our software. Now let's see the third and final example. Let's come here and let me minimize this. Let me collapse this and open this. Let's see that here again we have an array that is going to have 10 and 100,000 elements. And then in here, what we're doing is something very simple. I have this array, ordered by descending, ToList, and then for each. And then I do something with this. The author says that this ToList here and combined with this for each is unnecessary because it allocates too much memory. So it is preferred to do something like this, using a humble and simple for each. We do a for each here, bar item in array.orderByDescending, and then again do something with each item. Alright, so let's see this. Let's come here, let me say example 3, and let me run this. So here we have the results of our experiment. Here we have ToList.forEach, which uses the ToList, and for each without the ToList. As we can see here, in the case of 10 elements, there is a difference of 10% in terms of speed, and in the second one, where we use 100,000 elements, the difference is of about 14%, which is a decent improvement. And also in terms of memory, you can see here that in this case, the improvement is of 25%. Just by not using the ToList for each combination, we saw an improvement of 25% in terms of memory, which again may seem small in this application, but in a big application where we have thousands upon thousands of users, these small improvements add up, and therefore these advices should be taken into account.